All right, hello everybody. Thank you for joining us today. My name is Scott Delandy. I'm with Dell Technologies, and I'm joined here with Drew Tonnesen, who's also with Dell Technologies. And what we want to do is we want to spend a couple of minutes talking to you about some really cool things happening on the storage side of things around some next-gen technologies, some of the things that we're doing around our storage strategy, and then we also want to share with you some of a little bit of a tech preview of some of the things that we're working on with VMware that you'll see being introduced in the future. All right, so with that, let's go. So from a storage perspective, one of the real core parts of the infrastructure that supports many mission critical virtual environments is the PowerMax, right? It's a system and a technology that's been around for literally decades and really was one of the first platforms that enabled things like VMware to move out of test and dev environments and become really a core way of deploying production applications because of the resiliency and the data services and the performance and the scalability. So lots of cool things have been happening for a long time with the platform. One of the recent things that's been transitioning in the storage industry is a whole bunch of things around the technology and the components that go under the covers to basically support the systems that we're developing today. One thing that has been changing is the connectivity, right, to the media itself, right? If you look at mechanical drives and how those drives are connected, they've been using older protocols that were designed back in the time where latencies were measured in tens of milliseconds. So the need to reduce latency and provide higher performance really didn't matter as much because of the slowness of the media. Well, now that we're all running flash-based systems, hundreds of microseconds become really important. So the media is now transitioning to NVMe as a protocol, which provides a tremendous amount of performance advantages around latency, higher I/O, queue depths, all those cool things that really allow you to take advantage of the flash technology that we're using today. One of the other things that's changing under the covers is the media types, right? We went from hard drives to flash drives, and now we're moving into even faster solid state technology with things like storage class memory, or what you might know from the server space, things like Optane technology from our good friends over at Intel. This allows us to take the media itself, which goes from hundreds of microseconds in the world of flash to literally tens of microseconds when we look at things like storage class memory. And the final transition that we'll see happening is the connectivity from the host perspective, where we move from direct attach to now having networked connectivity with things like Fibre Channel and iSCSI to now new protocols with using NVMe that run not just from the back end media, but all the way to the front end of the host, right? So what does this mean and why is this significant? Well, just to share with you some of the kind of the engineering data around why this is a big deal is if you look at the orange line here, this is where we were like a year ago, right? You had a flash drive and it was connected over a SAS-based protocol. And you got really good performance with it. Your sort of baseline for doing an I/O was a couple of hundred microseconds, and you could push that out to a couple of hundred megabytes per second in terms of the amount of throughput that you could support on that drive. Where we are today is now we've got NVMe connectivity going to that same media. So your latency is about half, about 100 microseconds to read and write off of the drive, and you can about double the amount of throughput that you can push to the drive. So that's really cool technology. A lot of things that you can do, especially for performance-sensitive workloads where latency and I/O is really important. Where we're going now is now we're introducing things like Optane or storage class memory, where we're even lowering the response time to tens of microseconds, and we're pushing the amount of throughput out to gigabytes worth in terms of how much data we can now move on and off of that drive over a single set of connections, right? So really cool stuff. And again, think about your virtual environments and these really heavy I/O and latency sensitive workloads. That becomes really important. Now, when I show this green line to everybody, everybody asks the same question. What's that question? You're absolutely right. How much does it cost, right? So obviously for that level of performance, there is a premium associated with that. So one of the things that we've been working on in engineering into the systems is how do we give you the ability to take advantage of all of that performance and all of those capabilities of that new media and those new connectivities, but not give you another thing that you have to manage, another thing that you have to tune. We wanted to build intelligence and automation into the system so that if I've got data stores that have hundreds of VMs And when I look at my VMs, and I've got some of those VMs that are really active and some that aren't as active, how do we not just take the active VMs and put them on the higher performing media, but how do we go down at a lower level of granularity, so even within a VM, we can figure out which parts of that VM can take advantage of the technology, and just by putting a small percentage of overall capacity with this high performance storage class memory, really be able to give you not just good performance, but also give you very attractive economics to be able to speed those things up. So that's what I wanted to talk to you about, and then what I wanted to do is have Drew come in and spend a couple of seconds actually showing some of the things that we're working on VMware with to make this real and to be able to get this deployed in the data center. So let me switch you over. Yay.
All right, so I'm going to pause here just for a second. I'm going to do the big reveal before I actually even start the demo. The object here is I want to show you how easy it is to go from your existing technology of the protocol of Fibre Channel to FCNVMe or NVMe-OF, however you want to describe it. Right? So what we're using here is next generation vSphere. So there's no, I can't give you release dates or anything like that. VMware obviously will have those. But what I'm going to demonstrate is how our FCNVMe works with vSphere and how you can take your existing environment, your infrastructure, your virtual machines, and just move them over to FCNVMe online, without any downtime.
And I think it's also important to talk about just the engineering relationship that we have between Dell EMC storage and VMware in order to help kind of take these things and take the two of them and put them together so that users can take advantage of it.
So we work with our engineers all the time. This is how we got to where we got here with this. We were the first customer we worked with on FCNVMe because for us, FCNVMe is GA already, so we're ready to go. So we're already supporting operating systems, but vSphere is not available yet. So this is, you can see here, here's the storage resource pool. I'm going to point this out because Scott was talking about this. We have a resource pool that has both EFD and SCM. So it's got the Optane drives in here, so that what we'll do is we can take little pieces of data that are made up inside your virtual machine and move them up to SCM so that you get the best performance. Right? Most of the data inside a virtual machine is fairly static, right? But there's a good, there's a 20% portion that needs that top level speed, the best performance, and we'll move that for you so that you'll get that within the box. And this is all, artificial intelligence, machine learning behind the scenes. You won't have to do anything for this. So what I'm showing here is I want to show you the two different types of protocols. So this is in the same PowerMax. This is our high-end array. So we have FAs, which are traditional Fibre Channel, and then we have another emulation, which is called FN, and that's FCNVMe, right? So I'm just showing you the switch here to show you there's nothing going on. I have both of these are on the same 32 gig switch. By the way, you could have a 16 gig switch. We support that also, but the array itself is 32. That's our emulation. And what I'm going to do is I'm going to create a port group for the FAs, Fibre Channel, and then a port group for FCNVMe. So I'm going to have two different port groups. And on the PowerMax, what we do is we associate that with HBAs and devices, and that's how a host sees them, right? All storage vendors do kind of the same thing in some way, right? You're basically presenting storage, masking or unmasking, however you want to describe it. And so that's what I'm going to do here. I'm going to present the storage, two different sets of storage, down to the array. The other thing I wanted to note about the storage is there's nothing special about the storage on the back end in terms of presentation. So if I'm presenting a data store right now down Fibre Channel, and I decide I can take downtime, I could shut the virtual machines down on that device, on that data store. I could move that data store over to FCNVMe, represent it back to the environment, and now I'm running on FCNVMe. Right? So if you have massive migrations to do where you could take downtime, you could do that. I'm showing you doing it online so that you don't have to take downtime. So here's my two different storage groups, my FC storage group, and you'll see FCNVMe is always going to NVMe for the label. So I use two different size devices, one 400, one 500, just so you can see the difference. And now the masking view is how we present storage down to each individual host. So we're going to present the 400 gig down and then the 500 gig down. So let's get to the good stuff. So here we're going to go into vSphere. This is some future vSphere version.
What's the password?
vSphere.next, I guess we call it. So you can see I have two different resource groups. So I have my Fibre Channel virtual machines, I have my NVMe virtual machines. Okay, and so what I'm going to do is I want to move this protocol over to this protocol. Okay. So here's my two HBAs for FC. And you can notice down here the NAA number. I'm sure you're all familiar with that. That's how Fibre Channel gets presented. NVMe gets a different type of naming convention. It gets this universal ID, which is an EUI. You may actually recognize it if you use iSCSI. So here we have NVMe Fibre Channel disks EUI. Okay. The other thing that changed is if you use multipathing, native multipathing from VMware, you're very familiar with NMP, which is just their regular native multipathing. They're using a new one for SCM vMe called HPP, so high performance NVMe. For all intents and purposes, just consider them the same. They're just different because they're two different protocols. Okay, they'll have the same functionality, same capabilities. And you can see down here, presented with my round robin. So that's my traditional Fibre Channel devices. And then I'm going to show you what it looks like for NVMe. So once again, in this case, I'm actually using latency. So this came out with vSphere 6.5U1, where you can actually set latency for NMP instead of using just traditional round robin. So I'm going to select one of my virtual machines. I'm just going to storage vMotion it, right? I'm going to bring it from my data store that is Fibre Channel to my data store that's NVMe. All this stuff done online, all in the back end.
All right, that's pretty cool. So where can we go to get some more information on this, Drew?
You mean my blog?
Yeah, you gotta plug the blog.
So I have a blog, which was my tag name there. It's drewtonnesen.wordpress.com.
So you don't even have to remember that. You have to remember three things. Just Google Drew, Dell, VMware, and it'll come up on one of the first things, because that's how I find you. So, all right. So we're out of time. We want to thank everybody for showing up. We got some smart people hanging out here. We've got some smart people hanging out at the booth. So if you want to come and get some more information, learn about some of the other things that we're doing with VMware, stop on by. But thanks for everybody's time.